it changed again. You saw word to vec, I could learn about words. Well, now I can learn about sentences. And this was transformational for another reason. Translation, machine translation. You all just take it for granted that you can translate anything to anything else. It used to be the most complicated thing ever. It was called statistical translation or statistical sentence translation or something like that. And how they used to do it was they used to take little snippets of sentences from like big books like the UN Charter, where you've got it in all these different languages, and they would take the sentences and map them to each other. And then they would learn features and they would fine-tune this. You had hundreds of people trying to fine-tune. And that was statistical machine translation, been going for like 20 or 30 or 40 years in 2017. And it was expensive to run, it was difficult to get right, it was prone to errors. In 2017, this attention architecture is basically this idea of a neural network that is capable of looking back over the string of words that come before and potentially after, and assigning a weight to each one based on context. That's the layman's version. And what happens is this model, they train it on English to French, and it obliterates the existing thing. So now all you need is this neural network. You train it up, and to run it's super cheap. And this idea that a neural network can emulate some much more complex algorithm was also transformational. It led to the whole discipline of scientific machine learning, which is where I've got like a weather model, which takes up millions of supercomputers, and then I just train a neural network to replicate it, and suddenly the neural network is super cheap and super fast. That's how your weather works right now. I was still from the days when weathermen never knew what they were talking about. But this transformer was, we thought it was just for translation, and then suddenly things exploded.